can also do with sequences and series. Series in this case is we can use something that's called sigma notation. So that's this letter here. And what this means is it just means to add. Okay, so it means we're going to have some rule here. This is starting place. This is the end. So that's the start. That's the end. And we're going to substitute these things in. We're going to do it up to this number and we're going to add them. So let's start. So we need to start at 1. So when r equals 1, 2 times 1 is 2, plus 1, it's 3. So the first term in this series is 3. That's also a, isn't it? It's a, or the first term. What's the next one? Well, you try r equals 2, so you go up in integers. So 2. 2 times 2 is 4, plus 1 is 5. Can you guess what the next one's going to be? It's going to be 7, isn't it? And this will go up to 11. Let's just check. 2 times 5 will give us 10, plus 1 is 11. So these are the terms in your sequence, and the sigma means that we need to add these together. So we can get rid of those commas and we can add those together. And that's all we need to do. This case, this is an arithmetic sequence, but it doesn't have to always be an arithmetic sequence. So we've just seen this one here. Let's have a look at the next page. So we know that. We know it's 35. Yes, we can work that out. So let's have a look at some more examples. So starting at 1 up to 7, here's the rule. It has n instead of r this time. So 1 times 3 is 3, and then it's going to be 2 times 3 is 6, and then 9. Okay. What are my values? So all the same stuff we did before is still the same. A is going to be 3, isn't it? D, because it's an arithmetic sequence, a difference will be 3. There is no r, that's for geometric. And n, I recommend counting these out at the start until you're very happy. So 1, 2, 3, 4, 5, 6, 7. N should be 7. It will not always be that simple. Okay, plugging it into your formula as before, should be able to get something like this. This is the 2a plus n minus 1d divided by 2 times r. Over here, what have we got? We've got 10 minus 2k, starting with 5. 2 times 5 is 10. The first term seems to be 0. What happens next? So 6, it'll be minus 2 and then minus 4 and so on. Okay? How many terms are there? There's term 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's right, there's 11 terms, not 10 terms. 1, 2, 3, 4 are missing. Okay, you need to be very, very careful. This is a very common mistake. This one here, it looks different. It has a power instead. You're going to see this is going to be geometric. So k is 1. 1 minus 1 is 0. First term is 5. K is 2. 2 minus 1, 1. 3 is going to be 15. So 5, 15, etc. Adding it up all the way to 12. Okay, the 12th term. And finally, the same kind of idea here at the bottom. We can skip some terms. Don't worry about this different form yet. We'll come to this later. So the idea is you should substitute in the first few, spot the pattern, get your key values, and then do the same as before. Okay. The advantage with this as well is you can use the ClassWiz calculator to check your answer, but you still need to show the key values being found and substituting into any formulae. One more example. 7 plus 2r. Let's do this one here. So how many terms do you think there will be? There will be more than you expect, won't there? You might even want to count these ones to start with. What could we do? We could start by plugging in some numbers to see the pattern. Okay, and we get 27, 29, etc. You're counting on the 10. You're starting from the 10. So you will have those 20 terms and one more. There'll be 21 terms. The method on the right is an alternative. What you can do is you can say the 10th to the 30th terms is the same as the first 30, take away the first 9. If you're doing further maths, this is the technique that you should use because it will be more useful later.